Hi, welcome back. This is Professor Ridge, and today's lesson is on section 6.8, partial fractions. So let's review. If I asked you to add two fractions, two rational expressions, like this, we want to get common denominators, which would be x plus 2 times x minus 3. So you get common denominators. And then we're going to distribute the top, so 3x minus 9 plus 4x plus 8 all over the common denominator. Combine like terms. So that's how you add two fractions or rational expressions. Now what happens is in calculus sometimes we want to write that expression, instead of simplifying it, we want to split it apart in these two simpler fractions. So the question is, how do you go backwards? And if I start with 7x minus 1 over x plus 2 x minus 3, how do you go backwards and write it as a sum of two simpler fractions? Okay, so in calculus, it's a lot easier to do some. It's a lot easier to do some work if you can write this fraction as these two simpler fractions, 3 over x plus 2 plus 4 over x minus 3. So the answer is, the way that you go backwards to get the two simpler ones is called partial fraction decomposition. Okay, so here's how you do it. So we take and write, we factor the bottom, which it's already factored, and we're going to split it up into the sum of two fractions with each factor as the denominator. And since we don't know what the top's going to be, we just put an a, b as variables. Okay. Now, our first step from here is we're going to multiply both sides by the LCD so we can get rid of all the fractions. Okay, so if we multiply both sides by x plus 2, x minus 3, you're going to get 7x minus 1 equals a times x minus 3, because the x plus 2's will cancel, plus b times x plus 2, because the x minus 3's cancel. Now there's a couple techniques to use from here. The way I'm going to do it is I'm going to stop. I'm just going to take this equation and I'm going to choose values for x and see if I can figure out what a and b are. Okay, so what I'm going to do is I'm going to pick an x that makes this thing equal to 0. Okay, so that would be x equals 3. So we're going to let x equal 3, and we're going to plug it into that equation. So 7 times 3 minus 1 equals a times 3 minus 3 plus b 3 plus 2, and we solve this. So we're going to get 21 minus 1 is 20 equals 0a, which is 0, plus 5b, and then you're going to divide both sides by 5. So b equals 4. Okay, now you're going to pick a number that makes the other one 0. Okay, which is negative 2. So we plug it in, back to that equation. 7 times negative 2 minus 1 equals a times negative 2 minus 3 plus b times 0. I just ran out of room there. Okay, so that's going to give me negative 14, negative 15 equals negative 5a. Then I solve that, plus 0, right? And then divide both sides by negative 5. So I can just ignore the 0. So a equals 3. And then you can see then, by this work, then we know that 7x minus 1 equals x plus 2, x minus 3 equals, now we go back to the original problem, a over x plus 2, and we know a is 3, x plus 2, and b we figured out was 4, x minus 3. And that's the partial fraction decomposition of 7x minus 1 over x plus 2 times x minus 3. Okay, let's try another one. So our first step is we want to factor the denominator. So we're going to get 13x plus 46 over, and I'll let you do it on scratch work, figure out yourself. So let's see, we get 3x minus 5 and 4x plus 3. Okay, so I want to explain how you did that. You just go back and review that if you forgot. Alright, so you factor the denominator. Now what we're going to do is we write the equation. We're going to split up the denominator into two fractions with each factor as the denominator of the individual fraction. So we get 3x minus 5, 4x plus 3, and then we're going to put a, b. And you just start with a. If we had 3 factors on the bottom, you start with a, then you do b, plus, and then do c. Okay, so you just do however many you have on the bottom. And you have to do it to linear factors, which these are linear factors, or irreducible quadratics, which means you can't factor it. Okay, and I'll show you an example in a minute. All right, so we start there. Now you're going to multiply the LCD on both sides, and distribute it, which is the LCD is going to be those two factors. So we're going to get I'll show it this one time. But I got 13x plus 46 times the LCD, which is 3x minus 5, 4x plus 3, over 3x minus 5, 4x plus 3, equals a times 3x minus 5 times 4x plus 3 over 3x minus 5 plus b times 3x minus 5, 4x plus 3 over 4x plus 3. So really it's helpful if you skip the step and just kind of visualize, okay, when I do the LCD, I'm just going to get the top, 13x plus 46. For a, the 3x minus 5s are going to be cancel, and you're left with a times 4x plus 3. And then for the b, the 4x plus 3's cancel, and you get b times 3x minus 5. So the idea is if you can skip that step and just write this, it makes this problem a lot easier. Okay, now from here, we're going to pick the two x's that make each factor become 0. So we're going to let x equal, so what makes this one equal to 0? And you just solve it. 4x plus 3 equals 0. Solve it. That would be negative 3/4. Plug it in to the equation. 13 times negative 3/4 plus 46 equals a times 4 times negative 3/4 plus 3, which is going to be 0. 3 times negative 3/4 minus 5. So now we're going to work that out. So we get, okay, so I get 145/4 equals negative 29/4. Now solve for b, so divide by or multiply by the reciprocal. So that would be negative 4/29, which gets us b equals negative 5. Okay, so now what makes this one equal to 0? So let x equal, you're going to solve that so that it equals to 0, so it'll be 5/3. Plug it in, so we get 13 times 5/3 plus 46 equals a times 4 times 5/3 plus 3 plus b times 3 5/3 minus 5. So that one's going to be 0. That one's going to be 0. And okay, work that out. So I get 203/3 equals 29/3. We multiply by the reciprocal. And I get 7. A equals 7. Alright, now I'm done. So my partial fraction decomposition of 13x plus 46 over 12x squared minus 11x minus 15 equals a is 7. And look at our original setup. Now some people, the order doesn't matter whether I put 3x minus 5 first or 4x plus 3. But once I set it up in that initial equation up there, a is now above the 3x minus 5. Now if I switched it, my a and b would have switched, but I would get the same answer when I write it out. That may have been a little confusing what I was saying there. B is negative 5 over 4x plus 3. Okay, so what I mean is that negative 5 would have been over 4x plus 3 no matter which one I called A and which one I called B. Alright? And 7 would have been over 3x minus 5 no matter what order I put it. So the 7 goes over the 3x minus 5 and the negative 5 goes over the 4x plus 3. Okay? Okay, so if we had repeated factors, so I have x minus 1 cubed, the way I have to set this up is you're going to put x minus 2 to the first, x minus 2 to the second, x minus 2 to the third. And so then we'll have A, B, C. So if this was x minus 2 to the fourth, then I would have plus D over x minus 2 to the fourth. So on. Okay, so you got to go up to whatever that power is. Power 3, so you do 1, 2, 3. If it's 4, you do 1, 2, 3, 4. If it's 7, you do 1, 2, 3, 4, 5, 6, 7. On top you have A, B, C, D. You know, go down the alphabet till you get to the 7th one. Alright, so the same idea. So now we're going to multiply both sides by the LCD, which will be x minus 2 to the third. And we're going to do the shortcut. So LCD is x minus 2 to the third. So on the left side, the whole bottom goes away. That's the whole point. And then we have A times x minus 2 twice, because we're multiplying it by 3, so 1 cancels. And then we have B x minus 2 once, and then C. Okay? So now we're going to let, the only thing that we can make equal to 0 is let x equal 2. So we're going to get 2 squared minus 2 minus 4 equals a 2 minus 2, which is 0. 2 minus 2 is 0. So we get c right off the bat here. So we get 4 minus 2 minus 4, which is negative 2. And we get 0 plus 0 plus c. So c is negative 2. Now just make 2 more choices for x. So let x equal, now just pick any other, and make them small. Now pick 2 other numbers other than 2. We try to 2 or so let's let x equal 0. That's easy to do. So we get 0 minus 4 equals a times 0 minus 2 squared plus b times 0 minus 2 plus c, but c we already know is negative 2. So we're going to get negative 4 equals 4a plus negative 2b. Okay, now we're going to let x equal 1, so you want to keep it small. So we're going to get 1 minus 4 equals 1 minus 2 squared plus b 1 minus 2, and we know c is negative 2. So we get negative 4 equals a minus b. So now, basically now we have a system of equations with 2 variables, and we're going to solve it for a and b. So take equation 1 and equation 2 and eliminate a variable. So let's take equation 2 and times it by negative 2. So equation 1 is negative 4. And equation 2 would be 8. Oh wait, I messed up. What did I do with this minus 2? So I gotta have the minus 2 here. So I'm going to add 2 to both sides. So I got minus 2 equals 4a minus 2b. We'll call that equation 1. And I got this minus 2 over here. So I'm going to add 2 to the other side. And I get minus 2 also. So we get 2 equals 2a. So a must be 1. And then we'll plug 1 back into equation 1 or 2. We'll plug it into equation 2. Negative 2 equals a minus b. Oops. 1 minus b. Subtract 1. So negative 3 equals negative b. So b must be 3. Okay, so now we know that a is 1, b is 3, and c is negative 2. Okay, so our solution is going to be a is 1 over x minus 2 plus 3 over x minus 2 squared plus, now the book will put the minus out here, minus 2 over x minus 2 cubed. Okay, so that's the partial fraction decomposition. Okay, so whenever you have repeated factors, you start with the factor to the first power, then you go to the second power, third power, fourth power, until you get to whatever the power is. So in this case it was cubed, so I do 1, 2, 3. Alright, so that's how you deal with repeated factors. Now let's look at one that has irreducible quadratic. Okay, so I got 3x squared minus 3x minus 8, and the bottom is x minus 5 times x squared plus x minus 4, and that doesn't factor any further. So that's what's called an irreducible quadratic. Okay, and this is of course linear. So the idea, you need linear factors or irreducible quadratics. Okay, once you get to that point, you split it up, and if it's a linear factor, x minus 5, you put a constant above it. You write a variable, but just a constant. So a is some number, plus, and for quadratics, x squared plus x minus 4, on top needs to be linear. So x minus 5 is linear, so above it we put a, which is a constant. There's no x. And then x squared plus x minus 4 is quadratic, so above it you just go wherever you are in the alphabet, so it'll be bx plus c. So that's a linear factor on top. Okay? So now you're going to multiply both sides by the LCD, which is the x minus 5, x squared plus x minus 4. So you multiply both sides by the LCD, 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 and you're going to get 3x squared minus 3x minus 8 equals a. The x minus 5's cancel, and you're left with the x squared minus or plus x minus 4 plus bx plus c, and the x squared plus x minus 4 cancels, and you're left with the x minus 5. Okay, so this is the equation we're going to work with. We're going to pick choices of x that will make the factors go away. So what's going to make that equal to 0? So we're going to let x equal 5, plug it in to our equation here. Okay, so that's 0. 0 times anything is 0, so that whole thing is 0. We get 75 minus 15 minus 8, which is 52. And we get 25, 26a. And that whole thing's 0, so we don't care about that. So we get 26a equals 52, divided by 26, a is 2. Now we're going to use the same technique that we did with the last problem. We're going to we need to figure out what b and c are, and there's nothing will make this 0, right? There's no x that's going to make 0. If I could make it 0, then that means I would be able to factor it. Well, we established that you can't factor that, so there's no zeros for x squared plus x minus 4. So I'm just going to make two choices of x, and again, usually you're going to use like 0 and 1, but you can choose anything, and then we're going to have a system of two equations with two variables. So we're going to let x equal 1. Well, let's start with 0. So we get 0 minus 0 minus 8 equals a 0 plus 0 minus 4 plus b times 0 plus c 0 minus 5. And then what we get here is negative 8 equals negative 4a plus c times negative 5. So negative 5c. So we'll call that equation 1. Now we're going to let x equal 1. Oh, wait a minute. We already know a is 2. So we're going to plug that in. Negative 8. Negative 4 times 2 is negative 8. So we're going to add 8. Well, so that makes it nice. It's going to make the problem a lot easier. C is going to be 0. Okay, so now we know A is 2, C is 0. Pick another number for x. So let x equal 1. And so we don't have to do the system of equations because this is going to work out really nicely. So we're going to do 3 times 1. So again, I'm going back to this equation that I boxed up here. 3 times 1 minus 8. And I know A is 2. I'm plugging in 1 for the x's. B I don't know. That's the one I need to figure out. X is 1. C I just worked out as 0. I'm putting in 1 for x. So let's see, we get 3 minus 8. It's minus 8 again. And then we get 1 plus 1 minus 4 is negative 2 times 2 is negative 4. B times negative 4, so it's negative 4b. So add 4 to both sides. Negative 4 equals negative 4b. Divide by negative 4, so b is 1. Alright, so now we're ready to write our partial fraction decomposition. So a was 2 over x minus 5 plus bx, so that's 1x, so you don't have to write 1x, plus c is 0, so you don't have to write plus 0. Here, I'll do it just over x squared plus x minus 4. So of course you wouldn't write it like that, you would write it like 2 over x minus 5 plus x over x squared plus x minus 4. Okay, so that's the partial fraction decomposition of the original fraction. Alright. So that concludes the lesson for 6.8, partial fraction decomposition. Go to My Math Lab and do your exercises there. See you next time.